Real generated dust from unsealed haul roads is the primary emission source of suspended solids from coal mining activities. The generation of airborne particles causes deterioration of air quality and is one of great concerns to both employees of the mine and residents surrounding the area. Prolonged inhalation of coal mine dust is known to cause severe respiratory health issues with few medical treatment options available. The requirement for measurement and reduction of traffic-generated dust holds great importance across mining communities. Coal dust is primarily made up of hydrocarbons and metals, each responsible for many types of respiratory failure and disease, including emphysema and chronic bronchitis. A rapid increase in respiratory failure in young miners has triggered the need for treatment research. However, given the risk of disease even after exposure has ceased, strategies for exposure prevention must be addressed. There are several dust control methods applied across Australia that can be separated into three major categories: road construction and maintenance, mechanical stabilisation, and chemical suppressants. These first two types of measure are preventive control types only. The selection of optimal road-based materials and drainage patterns, combined with regular mechanical stabilisation, will reduce the dust-generating potential of an unsealed road. However, such measures do not eliminate fugitive dust generation. Chemical suppressants are therefore used as a mitigation measure. Current EPA guidelines state that coal mines must be able to reduce traffic-generated dust by 80% through the application of dust suppressants. Dust suppressants agglomerate fine particles, increasing the density of the road surface materials. This reduces the ability for vehicle tyres and air turbulence to lift particles into suspension and decreases the potential for particulates to cause harm to human health. Types of suppressants that may be used range from a basic water mist to the application of petroleum-based and microbiological binders. However, the effectiveness of each suppressant is dependent on many different factors, especially climate. For example, some chemicals are more effective in a dry environment and others are less effective in humid conditions. In a study undertaken last year, over 90% of the coal mining companies surveyed indicated that visual evaluation and road user feedback were their primary assessments of suppressant effectiveness. To ensure good health of the employees and community, the mitigation strategy that results in the highest reduction must be chosen. Therefore, a reliable measurement of vehicle-generated dust must be capable. A developing method for the measurement of vehicle dust involves a high-volume mobile dust sampler mounted to the back of a vehicle with its air intake positioned directly behind the front passenger side wheel. Powered by a 12-volt fan, the sampler will collect an air sample, and then further analysis will determine the weight of dust per volume of air. This should be done before and after a suppressant is applied to calculate the relative reduction percentage. The results can then be compared to determine the most appropriate suppressant suitable for the environment and conditions of the mine and haul road. Compared with sampling methods used in previous field studies, the mobile sampler is the most time and labour efficient and provides greater reproducibility. Using the mobile sampling method, it is highly recommended that coal mines investigate the most suitable dust suppressant for their haul road. Large industrial companies have the responsibility to care for their employees and communities' health. They should not just aim to meet the requirements, but beat them.